Question number 44. Let's do it. So all of these questions you should first try first, and then press play, and then press pause and play, and pause and play, and really try your best to be independent as much as you can. In 44, I want to integrate this. What do I notice to integrate this, if you've looked at it, is the first thing I look at is when I see a fraction, I look at the denominator and I take the derivative of it. So if I take the derivative of the denominator, does it match the numerator? Are they like terms? And the answer is yes. So for number 44, what I'd like you to do is I'd like you to take the derivative and you get 2x. And then after you take the derivative, you need a fraction in front that keeps them equivalent. So I need a 1/2 so they stay the same. Then you can unhook, and this is a logarithm. And you're done. Oops, that's a minus. So it's 1/2 ln x squared subtract 4 plus c. So the answer is actually c. Right there, that's the answer. Number 45. In number 45, you're given the graph of a piecewise function. You're asked to integrate it. So to integrate from -1 to 4, press pause and think about it first. But after you think about it, if you need support, what does it mean, integration? And it's to find the area under the curve. Area above is positive. Area below is negative. Find the area of the trapezoid above, or you can break it down into a rectangle or triangles. Find the area below. Again, you can break it down into a square and a triangle or a trapezoid, however you want to break down the shapes, and then combine them together and find the answer. So try it first. So I'm going to have 2 trapezoids. So if you've tried it, try it and then see if you did it right. So my top trapezoid, the area of a trapezoid is 1/2. The height of the trapezoid is 2. And then the bases, one base goes from -1 to 2, so that's 3, plus the other base goes from 0 to 1, so that's 1. And then I'm going to subtract the other trapezoid. So the height of the trapezoid is 1. It's 1/2 times the height of it. And then the bases are 2 and 1. All right, so this is what I got. And then just finish it off. So 1/2 times 2 times 4, 1/2 times 3. So it's 8/2 minus 3/2. Notice I kept common denominators. That's 5/2 or 2.5, and the answer is B. All right, number 46. Try number 46. Just integrate it with the integration rules. Remember, there's a hook. Press pause, try it, and then press play. This is my work. The derivative of 3x is 3. That's the hook I need, so I need a 1/3. So it stays the same question. Then you can unhook it. So the answer starts with 1/3. The antiderivative of cosine is sine. And that's it. So it's 1/3 sine 3x. So the rule for cosine, the antiderivative of cosine is sine. Positive 3x plus c. And that's the answer to D. Number 47. So we have e to the root x. And I always find it helpful for these to write it calculus friendly when I see this. So if you want to write it calculus friendly, what would it look like? So I would integrate, and it's e to the 1/2, x to the 1/2. So I'm going to write down, so the denominator would be x to the negative 1/2, and the numerator be e to the x to the 1/2. So this is what it would look like calculus friendly. So the square root of x that was in the denominator is now a negative exponent and a fraction. And the square root of x is x to the half. So that's the same thing. Now what would I do? So the hook comes from the exponent. So the derivative of x to the 1/2 is 1/2 times 1 in front. And then subtract 1 to the exponent. So that's the hook that I need. That's the derivative of x to the half. Compare, they're like terms. I have a 1/2, so I need a 2 in front so they stay the same. Then I can unhook it, and the rule for E is copy it. And it's done. So it's either x to the half or the square root of x and then plus c. So that matches with A. Number 48. So I want you to look at 48 and then press play. So look at 48, press pause, and then play. So the derivative of e to the x is e to the x. So unhook this, and it's just ln 1 plus e to the x plus c. So the answer to there was, I think, B. 49. Again, press pause and try it, then press play. The derivative, where does the hook come from? And so the hook comes from x squared. So the derivative of x squared is 2x. So you need to write down 2x. So I need a 1/2 in front. So simply the 2x goes away. It starts with 1/2, unhook, and then the rule for E is copy it. So it's 1/2 e to the x squared plus c. So the answer is A. Number 50. Press pause and try it, and then I'll tell you how to answer it. For this one, do you notice the numerator is more powerful than the denominator? So this is going to require long division to begin with. So if you notice that the numerator is more powerful, that you had to do long division, then that's what I want you to do. So press pause and do long division, and then press play. So x squared divided by x is x. If you multiply, you get x squared plus 2x. Subtract, you get the remainder of negative 3x. Again, negative 3x divided by x is negative 3. Multiply, and you get negative 3x minus 6. Be careful when you subtract the negative. So the remainder is positive 1. So then how do I write this properly? Is I take the answer. So I'm integrating, again, from 1 to 2. So what am I integrating from 1 to 2? The answer, which was x subtract 3, and the remainder, which is 1 over x plus 2. So I had to do long division, and that's the remainder, and still integrating. So to integrate x, you would add 1 to the exponent and divide. To integrate negative 3, it's negative 3x. And then the last one is just a logarithm. So it's ln x plus 2. Notice the derivative of x plus 2 is 1, so I don't need a number in front at all to keep it the same. The hook is correct. It's just a logarithm. And now I'm still integrating from 1 to 2. So now the next step, I plug in the upper bound first. And then I subtract, and I plug in the lower bound. I'm going to put parentheses there because you got to combine first and then subtract. So this is what I have so far. Now I'm going to start simplifying this. So 4 divided by 2, I got it. That's 2 take away 6. So that's negative 4 plus ln 4. For the next one, that's 1/2 take away 3. So 1/2 take away 3, that leaves me with negative 5 over 2. Or 2.5. So 1/2 take away 3 is negative 2.5 or negative 5 over 2. Oops, we still have a ln 3 here. And now we're going to combine like terms. So we have negative 4 subtract a negative. So it's really negative 4. I'll get like terms here. So, I mean, common denominator. So I'll make it negative 8 over 2. When you subtract a negative, you're adding 5 over 2. So those are those numbers. And then I have ln 4 subtract ln 3. So I'll put the logarithms beside each other. So first of all, negative 8 plus 5 is negative 3 over 2. And then if you look at the answer, they want you to know, do you know your logarithmic properties? So if the bases are the same and you're subtracting, that means you could write it as one logarithm by dividing. So they want to see if you remember how that you could divide to write this as one logarithm. And that's it. So the answer to number 50 is A. All right, let's look at the next one. And I'm real proud of you that you're putting the work into this. 51. So press pause, look at it, and when you're ready to work with me, press play. So when I look at this, I think of arctangent right away because of the form of it. The fraction 1 plus something squared, like this is arctangent, the form. So if that's arctangent, the things I look at are this. What does u and a equal? So first of all, a is simple. A is the square root of 1, which is 1. U is the square root of this. Well, square root and square, they undo each other. That's e to the x subtract 1. And then the derivative of that is just e to the x. And it all matches. So when I take the square root and then do the derivative, the hook matches exactly. There's nothing I need to do to undo anything. So this is the values I have so far. So a is 1, u is this, and this is u prime is used to make sure the numerator matches exactly. So now when I integrate this, you'd actually start with a fraction, but it's 1 over 1. So I don't need that, but it does start with 1 over a. So it's good to remember that. Arctangent, and then it's u over a. So that's completely, the 1's in the denominator don't change anything. And then I'm integrating from 0 to ln 2. So there's that. So really what I have is arctangent, and then I'm going to plug ln 2 in first. So e to the ln 2 subtract 1, and then subtract, and it's arctangent, and that's 0. So e to the 0 subtract 1. So that's what I have so far. Now can I simplify this? So I have arctangent, e and ln undo each other, so it's just 2 subtract 1, so it's arctangent 1. Here, e to the 0 is 1, and 1 take away 1 is 0, so it's arctangent 0. Now I'd like to tell you that there's an answer that matches that, but there's not. You need to know your unit circle to go the next step. So at what angle does tangent equal 1? Remember, tangent is y divided by x. And so the angle where tangent equals 1 is 45 degrees, or pi over 4. That's when the y and the x have the same value, root 2 over 2, root 2 over 2, and they make the answer 1. Where does it equal 0? That's here at the right side of the unit circle. So at this point, 1, 0, when you go y divided by x, 0 divided by 1, that gives you the answer 0. So that's angle 0. So the angle is pi over 4, subtract 0, so the answer is pi over 4, and that matches with C. So not only did you have to know your calculus and recognize arctangent, you then need to know the unit circle to match the answer in multiple choice. If this was not multiple choice, if it was free response, you could have actually left the answer like that and gotten full credit. Number 52. In question number 52, once again, you look at it and then I'll look at it. We'll do it together. But first you need a moment. So press pause and look at it first, then press play. So the first thing I see when I see there is I see the adding. And when you're adding, you could just integrate each one separately. So I'm going to write it as 5e to the 2x plus, I'm going to integrate 1 over x dx. So I'm just going to write it as two different integrations like this, and then go from there. So the hook should be 2. So what it was over what it became, so it's 5 over 2. This one's perfect, it's ready to go. and then what's the answer? So to integrate, the 2 goes away. We have 5 over 2. The integration rule for e is copy it. The integration rule of 1 over x is ln x, and that's it. And then it's plus c. So that answer is B. All right, question number 53. In 53, what's the antiderivative of that? And again, when I see x squared minus 2x plus 2, I'm going to have to complete the square. It's going to be arctangent. So already I know the answer is E in terms of the setup, because that's the only one that will set up to be arctangent. But let's go through the rules in case it's not that simple, where there's only one arctangent to like pick. So do you remember how to complete the square for that? So I'm going to go x squared minus 2x. And to complete the square, I take the b value, which is negative 2, and I divide by 2 and square. So let me show you that. So take the b value, the linear coefficient, and it's negative 2 divided by 2, and square it. So that answers 1. So that's what I need. Now the number that was there before was 2. So 1 plus 1 is 2, so they're equivalent, but that's what I'm looking for. Remember, I'm integrating this. So now I'm going to complete the square. That's x minus 1 squared plus 1. And then how do I do arctangent? Well, a is the square root of 1, the constant, which is 1. U is the square root of x minus 1 squared, which is just x minus 1. And then u prime is the derivative of this, which is 1. Then look at the numerator. They match, so they don't need a different fraction in front or anything. We're ready to go. So the answer here is 1 over a, which I don't really need if a is 1. Arctangent u over a. And then the constant. Done. So which one matches that? We already knew that. So notice it says an antiderivative. So it's just one of them. So you don't need the plus c the way they worded the question. But you can see arctangent x minus 1. 54, try it, then I'll do it. So press pause. So the first thing I know is the hook should be 3x squared. So it needs a 1/3. So it's just 1/3 and then the antiderivative rule. So it's 1/3 sine x cubed. And that answer is B. That's simple. Number 55. We're going to write it calculus friendly, but I want you to try it. So press pause, try it, and then you can try it with me. All right, this is what I've written down. So calculus friendly, that would be to the negative a half. The derivative of this is 6x. And then they're like terms, but I need a 1/6 in front so it stays the same. And now the antiderivative would be 1/6. The hook gets unhooked. You add 1 to the exponent. So negative a half plus 1 is positive a half. Instead of dividing times the reciprocal, so that ends up being 1/3 or over 3. So that's going to match with D is the correct answer. Number 56. Take a look at 56. Try it first and then press play. So try 56. The antiderivative rule for sine x is negative cosine x. So it's negative cosine x, and then you need to know your unit circle. So it's negative cosine x from 0 to pi over 4. So you plug in the upper bound, subtract, plug in the lower bound, and then know your unit circle. So cosine at pi over 4 is the x coordinate there, which is negative root 2. Well, it's positive root 2 over 2, but it's made it negative. The x value at the angle 0 is 1. So a negative times a negative. So it's negative root 2 over 2 plus 1. Order doesn't matter, so it can be 1 minus root 2 over 2 or that. And that answer matches with D. Number 57. It's a calculator question. So press pause and get your calculator. It says let g be a differentiable function. So g at 4 is that. So it's called a starting value problem. It gives you a starting value, which is 0.325. And then it gives you the derivative, and that tells you the increase or decrease from there. So I'm going to add, and now I'm going to integrate. So 4 is my lower bound, and then I want to know 1. So 1's my upper bound. So we're working backwards, but because the lower bound is 4 and the upper bound is 1, it allows us to work backwards. And then it's just the derivative. And so then you just need patience and type it in and go from there. So I'm going to let you do that. So this is what you would type in. So you start with 0.325 plus, you're integrating from 4 to 1, 1 over x. Make sure you go times, and then e to the negative x, parentheses, cosine, x over 100, all of that. Then press Control Enter, and if you did it correctly, you should get the answer 0.109. So the answer matches with A. Practice using your calculator. On to 58. In number 58, you're given a table of values. Selected values of the twice differentiable function and derivative are given in the table of. What is the value from 0 to 6 of the integration of the derivative? So recognize that when you integrate the derivative, it's just f at x. So for 58, the antiderivative of this is just f at x, and you're integrating from 0 to 6. So the antiderivative is just f at x, and we're integrating from 0 to 6, and then we plug in 6 and subtract and plug in 0, and that's when you look off the table. So f at 6 is 2, subtract, f at 6 is negative, or f at 0 is negative 22, and that together is 24. And there's your answer. So the answer to 58 is C, 24. All right, 59. In question number 59, you're given a table of values. Again, always press pause and try it first. Using the intervals here, what is the approximation obtained from a left Riemann sum? That's rectangles. So the first interval, it goes from 2 to 3. So the width is 1. And then a left Riemann sum, you take the value, the height at 2. So the height is 6 using a left Riemann sum. Plus, the next one goes from 3 to 5. That's a width of 2. Use 3 for the height, and that's negative 2. The next one goes from 5 to 8. That's a width of 3. Use 5 for the height, which is negative 1. And the last one is 8 to 13. That's a width of 5. And then use 8 for the height, which is 3, and that's what you're calculating. So it's 1 times 6, then 2 times negative 2, 3 times negative 1, plus 5 times 3. If you did that right and did the work, the answer is 14. So it matches with B. All right, number 60. In number 60, press pause and look at it, then press play. Which of the following are equivalent to this? And so knowing which rules you can apply and which rules you cannot apply. So just so you know, dividing and multiplying, you can't separate integration that way. You can separate integrations with adding and subtracting, but not multiplying and dividing. That's not a property. So number 1 is wrong. For number 2, they did division. So if you did long division, so if you went x plus 2 divided into 3x plus 1 and did the long division, that's what you'd end up with. And for number 3, after the long division, if you did a substitution, so if you let u equal x plus 2, then it would be u. And if that's true, plug in 5 for x, and then 5 plus 2 is 7 is the upper bound, and 0 plus 2 is the lower bound. So 2 and 3 are equivalent. Long division, and then doing a u substitution for x plus 2, and then whatever the u substitution is, use that formula to change the upper bound and the lower bound. So the answer for that is D, 2 and 3. All right, look at number 61. Press pause and look at it first, and then press play. Same type of question here. Use long division. If used, so number 1 is wrong because you can't divide and be equivalent, only adding and subtracting. Number 2 is good because you're doing long division. And if you do long division correctly, that's the answer. And then for u, if you did the u substitution, so if u equaled 5 subtract x, and you plugged in 4 and you plugged in 1, oh, notice the bounds then got flipped around too. So if you actually plugged in, so I want you to notice something that happens here. If you plug in 4 for x, you get the bound of 1. So 1 would have been the upper bound. If you plug in 2, 5 take away 2 is 3. That would have been the lower bound. Notice how they switched the bounds around. So the way we would normally do it, the lower bound would have been 3 and the upper bound 1. So they made it so it was proper so that the upper bound is bigger. But to switch the bounds means you have to multiply by -1 or change the sign. So that's where this comes from. So that after you do that, you multiply by negative to switch it around. So 2 and 3 are right. They're equivalent, but number 1 is not. All right, number 62. A pump allows water to flow into a pool at that rate, and they give you a graph of 2t, which is just a linear equation with the slope of 2. T is measured in minutes, and it says, which of the following defines a function that measures the accumulation of water? So what accumulates from a rate is integration. So A and B are wrong. And you're integrating from this from 1 to x. So from 1 to x. So the only answer that is integration of it from 1 to x is D. That's the one that matches if you want to know the water that's been accumulated. An integration is an accumulator. How much has accumulated over a period of time if you're given a rate? In number 63, this one you have to be a good reader for. So you have the function g at x, and it says a point there is 5, 2. And it says let f be that function f at x, integrating that, and let h be the first derivative where it equals that from 0 to 7. If the line tangent to the graph of h at x is a, like you're trying to find that, it's parallel to the graph of f at 5, what is the value of a? So the idea of tangent to begin with is derivative. So if I read at the end of the question, I want to know what the derivative of f is at 5. That's the beginning part. So let's take the derivative of f at x. Now, when you take the derivative of f at x, the derivative and the integration undo each other. It's called the fundamental theorem of calculus. They undo each other, and it just leaves me with g at x. So the derivative of f at x is really just g at x when you actually apply the fundamental theorem of calculus. Then I want to know what the derivative is at 5. So to find the derivative of f at 5 is just the equivalent to g at 5. So this graph g at 5 equals 2. So this is my steps to begin with. So I recognize I need to find the derivative of f. When I apply the fundamental theorem of calculus, I get g at x. And then I want to find the slope at 5. So plug in 5. That's equivalent. Look off the graph, and the slope is 2. Then it says h then it says h at x, or the derivative of h at x, is x squared sine x over 3 And we're going to make it equal to 2 and solve it. Now, and that will give me the answer for A. So when you solve this, what's the value for this derivative where they're parallel, where they have the same slope? So when you type this in, I think it's a good reminder to do this. How would I solve that equation? So let's do that together. So to solve that equation, press menu and solve. So go menu, go algebra and solve. And then you're going to type it in. So it's x squared. Make sure you go times and then go sine. And it's x divided by 3. And then we want that equal to 2. And then we're going to go comma x. So there's the equation. The thing with the trigonometric equation is there could be an infinite number of answers. So we have to have the ability to put in a restriction to get the one answer we're looking for. So we're going to go control equals the vertical line. And then the restriction goes from, from 0 to 7. So then put in the restriction, like I only want the answer from 0 to 7, then control enter, and it would give you negative, where are we at? So it gives you 1.857. So the answer is B. So we only want the answer from 1 to 7, and then it's 1.857 is the answer from 1 through 7, and that matches with B. All right. Turn the page, 64. All right, so for question number 64, so let f be a function given by f at x, and it's the integration from -2 to x of g. So any question that sets up like this is testing your ability to do the fundamental theorem of calculus. Meaning that 99% of the time you're going to take the derivative and they undo each other. So f is equal to just, the derivative of f is just equal to g at x when you take the derivative. The table above gives values for fg and g prime. So let's just start there. So when the information that's given, f prime at x is just equal to g at x. Because when you take the derivative of both sides, f prime at x is equal to just g at x. That's a good start. The table above then gives that. It says, given that h at x is equal to 2x plus sine x, for what value of x is h at x equal to the derivative of f at 2? So the derivative of f at 2 is equal to just g at 2. So if we follow along here, the derivative of f is just g at x. So the derivative at 2 is just g at 2. So look off the table. G at 2 is -2. So then we just take our computer or calculator and solve that equation. 2x plus sine x equals -2. And it says, for what values would you get that? And so if you do, again, it's a trigonometric equation. So I would set up a restriction. When I look at the answer choices, in terms of it, I see the answer choices, like they could go from -1 to +2. Well, +2 would be too big because sine can't be. But anyways, -1 to like +2 would work. So solve this equation and then make sure that you only want the answer from -1 to 2. So I want you to try that. The answer you should get is this, -0.684. So whenever it's a trigonometric equation, you should put a restriction in. I looked at the answer choices, and -1 to +2 covers all the answer choices, and that allowed me to get that answer. All right, 65. In 65, you're integrating 12x squared, 2x plus 1 dx. I noticed that the numerator is more powerful, so I have to do long division. So I'm going to do long division to begin with. So 12 divided by 2 is 6x. That gives me 12x squared plus 6x. Subtract to find the remainder. -6 divided by 2 is -3. That's -6x minus 3. The remainder is +3. So I have the answer like this. So I have 6x subtract 3. The remainder gets written over the divisor. And now that's what I'm integrating. So I'm going to write this here. 2x plus 1, plus 3 over 2x plus 1. Now, because I'm adding and subtracting, I can just do each one separately. So the antiderivative of 2x is x squared. Add 1 to the exponent and divide. The antiderivative of 1 is just 1x. And then the antiderivative of this, the derivative of 2x is 2. So that's what it needs to be in the numerator. They're like terms. So I need a 3 over 2. So they stay the same. So it's x squared plus x plus 3 over 2 ln 2x plus 1, and then the constant. And that matches with C. '66. In question number 66, you try it first, of course. So what do I notice? I see a fraction, I see a square root in the denominator, so I think of arc sine, but I need to complete the square. In order to complete the square here, I need to first factor out a negative from x squared and 4x. And then to complete the square, I take 4, I divide by 2 and square it. So I need a 4, but if I add 4, I need to subtract 4. So it stays the same. So if I summarize all of this, this is what I get. So 12 subtract -4 is 16. And then x squared plus 4x plus 4, if you factor it, is minus x plus 2 squared. So that's factoring it and completing the square. U is the square root of 16, which is 4. Sorry, a is the square root of 16, which is 4. U is the square root of x plus 2 squared, which is x plus 2. And the derivative of that is 1. So this 8 can be written in front of the integration. And then it's just arc sine. And it's u over a. That'd be x plus 2 over 4 plus c. So that matches with D. They didn't have arc sine. They went sine with a little -1. But that matches with D. All right, 67. In number 67, again, I notice the numerator is more powerful than the denominator, so I have to do long division. So long division and completing the square, I want you to practice enough where you feel good with that. 4 divided by 2 is 2x squared. So that's 4x cubed plus 6x squared. Subtract to get the remainder, and then keep going. So -6 divided by 2 is -3x. The remainder here is 9x. And then 9 divided by 2 is 9 over 2. is 9 over 2. So 9 over 2 times 2 is 9x. 9 over 2 times 3 is just 27 over 2. So when I subtract, the remainder is a fraction. So that's going to make you uncomfortable at first, but there's your remainder. All right, let's go back now to the beginning and put it all together. So now what am I integrating? So now I am, where am I? There I am. All right, now I'm integrating the answer. So that's 2x squared minus 3x plus 9 over 2. And then the remainder is 27 over 2. And whatever the remainder is, in this case it's 27 over 2, you would put that number over the divisor. So there, if it's a fraction, you can actually, like if it was 5, it'd be 5 over. This is the same idea. This is 27 over 2. If that was the numerator over that, I can just put the numerator in front. All right, so I can just integrate each one separately again. So the add 1 to the exponent and divide. Add 1 to the exponent and divide. 9 over 2 would just be 9 over 2x. Now this last one's going to be a logarithm. So we're integrating the derivative of 2x plus 3 is 2. So to undo that 2, I need a 1/2 in front. So we have 27 over 2 plus we need the 1/2 so that I have the proper numerator. Then I can unhook it, and then it's ln 2x plus 3. So look carefully which one has the correct one, and notice this would be 27 over 4 because C and D look very similar. But you have to make sure that you took care of the hook to get the right number in front. All right, 68. Number 68, you have to do long division. I want you to do it first, then I'll do it. So did you do it? Then you can press play. Let's see what happened here. I think I did something. So it's 2x. Oh, when you subtract a negative, this should have been positive 3. So that makes that positive. See, one little mistake like that, right? So then positive 3, that would be negative. And then 4 subtract negative 3 would be a 7. You probably did that right and got a 7. I'm glad if you did. So then what do we have? So we're integrating 2x plus 3 plus 7 over the divisor. So doing long division. Now this is a definite integral, so we're integrating from 3 to 5. But there it is using long division. If you integrate this, you get x squared plus 3x. This is a logarithm. 7 is going to be in front of the logarithm. And now I'm going to plug in. So the derivative of x subtract 1 is 1. Needs a 7 in front. So the 7's in front, then the logarithm. Plug in 5 first. Then plug in 3. And then combine like terms. So 25 and 15. What is that? 40. Take away 18. So that's 22. And then we have 7 ln 4 subtract 7 ln 2. So if you factor out a 7, you get ln 4, take away ln 2, and you get your answer, which is C, is the one that matches. 69. In number 69, this is the question. We're integrating from 0 to 1. And the question has x to the 4th plus 2x squared plus 9. Now there's a little rectangle there. It just, graphic services, it should say dx, and the d didn't come out, just the little rectangle. I don't know why. Now I didn't write the first part because I'm going to take the derivative of the base. So that is 4x cubed plus 4x. And now look, how can they be equivalent? If I divide everything by 4, then x cubed plus x comes out. So 1/4 times this, they would be equivalent. Now I can undo the hook. I start with 1/4 and then write it down. Add 1 and divide, but I'm going to go times the reciprocal, and you're still integrating from 0 to 1. This simplifies to 1/6. Plug in 1. Subtract. Plug in 0. Now you have to have a little bit of number sense without a calculator. So this is 1 plus 2 plus 9. This is 12 to the 3/2. This one here is the square root of 9, which is 3, to the exponent 3, which is 27. So we have that. And then how do I go from there? Now, one way to do this, the denominator is square root. Now, I can't take the square root of 12. But this is really root 12 times root 12 times root 12. Maybe that's a better way to think of it. So it's root 12 times root 12 times root 12. Now, root 12 times root 12 is 12, and 12 divided by 6 is 2. So now we have 2 root 12. 6 goes into 27. Well, it's 27 over 6, so it reduces down to 9 over 2. Just divide by 3. And then root 12 is 4 times 3, so it's 2 root 3. So the answer that matches that is C. So number sense at the end. Number 70. In number 70, you're integrating. I see the denominator, so right away, I'm going to take the derivative of the denominator. 3 times 3. So the denominator is 3x cubed plus 6x squared. I'm thinking the answer is a logarithm, so I want to make sure if that's right or not. I notice the numerator is 1 degree less, which means when I take the derivative, it could match. That's what I'm looking for. So this would be 3 times 3, that's 9x squared. 2 times 6, that's 12x. And then 3, and the derivative of 5 is 0. Look at it. If I multiply everything times 3, they would match. So I need a 1/3 in front. So 1/3 would make it equivalent. So then I can undo all of that, and the answer is 1/3 ln of the denominator. And that matches with C. Exactly what I said. Number 71. I haven't gone back here for a while. All right, question number 71. There it is. So the function is increasing and concave down, and you're doing a trapezoidal sum. Which of the following statements is true? And they want to know if it's an overestimate or an underestimate, and why is it over, under, or under. So for these, I like drawing it. So I'm going to draw concave down and increasing, just to get a picture of it. So if something is concave down and increasing, if you did a trapezoid underneath concave down, what do you notice about the trapezoid is it's underneath, and it's an underestimate. It's not going over the curve to be an overestimate for the area. So we know it's under, and the reason it's under is because it's concave down, not because it is increasing. It's concavity for trapezoidal rule. So concave down, it means it's an underestimate. So therefore for 71, the answer is C. It's underestimate because it's concave down with the correct reasoning. If I look for 72, now it's a right. So press pause and read number 72. 72, it's a right Riemann sum. And so for a right Riemann sum, again, it says that it is decreasing. So if I have a decreasing function and it's a right Riemann sum, like give yourself a visual of that. What do you notice is the right Riemann sum is an underestimate. Look at the space underneath the line that we're not calculating for. It's an underestimate because it's decreasing. So two of them say that. So A or C, and now which one's right for a right Riemann sum? So now the second part for a right Riemann sum, the distance is going to be a squared subtract a, that's the width. In a right Riemann sum, you would use 4 for the height. That's why C is the right answer, because it uses the height of 4 to begin with. Well, A uses the height of 5. That would be a left Riemann sum. So the one that matches for 72 is C. '73. So read number 73 and think about it first and then press play. So you're integrating from A to B, both f at x and g at x. In the integration for f at x, the answer is 5. And then for g at x, the answer is -1. Which of the following must be true? So if the integration for f at x is a bigger number than for g at x, that means there's more area above than the other one when you combine it together. But does that mean the function is always greater than the other one from A to B? And then the answer to that is no, it is not always greater in terms of that. It could be, but G could be greater than F for parts. It just means that when you look at the whole thing, that one's 5 and one's -1. Anyways, one does not have to be true. But this one does. If you add or subtract them, you do get the answer 4. Multiplying has no property, neither dividing. So for integration, when you add them, you do get the answer 4. So the only one that's true is 2. All right, 74. What are the values of x there where it's equal to 0? So I'm going to do the antiderivative, make it equal to 0. So the antiderivative of that is t to the 4th divided by 4. So t to the 4th divided by 4 from x to 2, and we're going to make it equal to 0. So do the antiderivative and make it equal to 0. I'm going to plug in 2 to begin with. And then I'm going to plug in x. And then make it equal to 0. So 16 divided by 4 is 4. And then to solve it, I'm going to add x to the 4th over 4. I'm going to multiply by 4. Now, when I do the 4th root, the answer could be positive or -2. Both would give you the answer 16. Positive 2 and -2. So that's why the answer is D. It's positive and -2. Number 75 is a calculator question. So the calculator there, it says you're given h. Whenever I see this set up, you're going to take the derivative. So it says, on what intervals is h decreasing? So take the derivative. This is the fundamental theorem of calculus. Take the derivative. You're just left with ln. So I want it for increasing and decreasing, you take the derivative. So it's ln, it's x times sine x plus 5. I think for this one, it's easiest to graph it. and look at it. So I want you to graph that and see where it is negative. So when you take the derivative, this is what you're left with. Make sure you go multiplying between x and sine x. And we're going from 1 to 7. So if you did it correctly, this is what it would look like. So I want you to graph that just like that. Make sure the window. So I put a window of 1/2 to 7.5 because I looked at the answer choices. And the smallest answer choice was +1, so I went 1/2. The biggest answer choice was 7, so I went 7.5. Oops. And then graph it. And then I'm looking for what's below. So I press menu, analyze, and then I went to 0. I want to know what that 0 was. So go to the left of it, and then go to the right of it. And so when does it start decreasing? It's at 4.3. And then when does it stop decreasing is over here. And if you, again, you try it, go analyze 0, find the other 0, and you'd say it's 5.461. So the answer to number 75 is B. You're graphing it and finding where it is negative, below the axes. That's where it's decreasing. All right, number 76. For number 76, try it first. For 76, you're given a graph. It says the graph of that. So let G, again, do you notice this form that it is? So G is this integration. So when you take the derivative, so the derivative of G gives you increasing or decreasing or the relative maximum. So if you take the derivative of G, it's just f at x. So that's the first thing we need to recognize. So for 76, the derivative of G is just f at x. And then to know where there's a maximum, you're trying to find where is f at x. Where does it go from positive to negative? So right here. Oh. How about there? Right there. It goes from positive to negative. Here's negative to positive. That's a minimum. 6 doesn't cross over. The signs don't change. So only at +1 does it create a maximum. So that's why the answer is A. Number 77. Let f be this function. Notice the form again. So take the derivative. Any constant. It's just a substitution question. So again, the derivative of f is negative x squared. So the derivative of f is negative x squared minus x plus 6. That's the derivative. That's called the fundamental theorem of calculus. And then what they want to know is where is it decreasing, right? Or where is it increasing? So you first take the derivative, make it equal to 0, and solve it. So I could divide everything by -1 to make it easier. So I see the two values are 3 and -2. That's where it's 0. So those create my intervals. But I have to go back. I have to go back to the, before I divided everything by -1, I need to go back to this. I need to use this. So if I plug in -4, the answer is negative. If I plug in 0, the answer is positive. If I plug in 100 or a billion, the answer is negative. So where is it increasing? From -3 to +2. So the answer is B. Number 78, 79, and 80 are tricky questions. So I'm going to help you through it pretty quick. So another way to write a Riemann sum is to write it as an infinite sum using a sigma notation. There'll be one question on the whole exam like this, probably multiple choice. And so I don't want you to stress out by it. But I'm going to kind of explain it to you, but you're probably going to wait to the end and probably going to look at it and see which one makes the most sense. So for number 78, that's a Riemann sum as an infinite sum using sigma notation. The first part is the height, and the second part is the width. It's a Riemann. It's a rectangle. It's width times the height times the width. And so if I look at each one, it gives me that. So the answer to 78 is all three could be described using sigma notation here. So the answer for 78 is all three, 1, 2, and 3. The answer to 79, again, a Riemann sum can be described in sigma notation, going for an infinite number of rectangles. 5 over n, the n part there becomes the width, and this beginning part is the height. Which one could match it? Think of 5 over n as x, and that therefore this would be 2x times root 1 plus x. And so which one would match that? So the function gives you the height. So if 5 over n is x, then this would be 2x, and this would be 1 plus x. Which one would match? So the answer is D. Again, these are challenging. Cosine x squared, how could you write it as that? And so from 2 to 8, the width would be 8 subtract 2, which is 6, divided by n, how many rectangles you have. So it's 6 over n, so A is wrong. And then for the height, for a left Riemann sum, you'd plug in 2 to begin with. So if I plug in 2, the answer better be 2 squared. And so when I plug in 2, when I plug in 1 for k, it doesn't give me the answer 2 other than C. C is the only one that when I plug in 1 for k, it ends up being 2 plus 0, so it ends up being 2 squared. C is the only one that matches properly. I do not want you to get a headache over this. There'll be one question where a Riemann sum is described in sigma notation, and do your best to move forward. That's what I'm going to tell you for advice. 81. Can you do a Riemann sum off a table using intervals that are provided? So I want to do a left Riemann sum. So for 81, the first interval goes 0 to 25. So the width, just set up each one and just calculate it at the end. There we go. All right. So the first width is 25. And then a left Riemann sum, you would use 0, so the height is 4. The next interval, 25 to 30, that's a width of 5. Use 25, and the height is 6. And then the last rectangle goes 30 to 50. That's a width of 20. And the height, there you'd use 30, so the height is 8. And then that's what you would calculate. This is what it would look like. So that's 100. That's 30. That is 160. And then if you put that together, it's 290. So the answer to number 81 is A. Number 82. You're given a table of values. Again, you're doing a Riemann sum. Can you do a Riemann sum off a table? They're rectangles. What type of Riemann sum? It's a midpoint. So it says the first interval goes from 0 to 2. So from 0 to 2, the width is 2. And then midpoint, use the mid value, so the height is 5. The next one goes from 2 to 4, so that's a width of 2. And then the mid value would be -1 for the height. And then the last one, 4 to 6. The width is 2. The mid value would be 0. And that's what it would look like. And then calculate it. So it's 10, take away 2. So you get the answer 8. So the answer is E. We're almost there. 83. My goal is to try to get it close to an hour. It's a little bit over an hour. All right. So there's the answer. 83. On the graph y equals f at x, the slope at any point is twice the value for x. And this is a starting value problem. F at 2 equals 3. So the starting value of the function is 3. And then we're integrating from 2 to 3. And slope means derivative. It's twice the value of x, so it's 2x. So there's the setup to find the value. So the starting value, then integrate from 2 to 3. This is the formula for the derivative formula, but they said the word slope. It's twice the value of x, and now calculate. So the antiderivative of 2x, add 1 to the exponent. When you divide, it's just x squared, and we're integrating from 2 to 3. We're going to plug in the upper value, that's 9. We're going to subtract and plug in the lower value, that's 2 squared, which is 4. So 9 take away 4 is 5. So 3 plus 5, that gives you the answer 8. So the answer to 83 is C. For number 84, it's a calculator question. You should press pause and look at it first. So it gives you the rate and asked how much water is being pumped from 0 to 5. So to understand the accumulation of water, you integrate a rate. So all you have to do in your calculator, and I'll let you actually do the calculator work, is you're integrating. So you're integrating from 0 to 5, that rate. So this is what it would look like. So you integrate from 0 to 5, that, and there's your answer. So the answer is 47.193. So that matches with D. Number 85, you're given a table for 85. And it says, use 4, and there's like a graphic services weird thing happening here. So if you look at it, it does this, right? What it meant to do is this. So 0 to 2 are the bounds, and they don't look like it, but can you rewrite it this way? And then if I'm doing a trapezoidal approximation, find the width. So I'm going to go the top, subtract the bottom, and divide by 4. So the width of each trapezoid is a half. The formula is 1/2 times the width. And then the first height in the trapezoid is 3. And then you double, and then you double, and then you double, and then you don't double. That's the form for trapezoidal rule. So it's 1/2, 1/2. So take the first height, then you double the height, double the height, double the height, and then you don't double, and then you calculate it. You end up with 48 divided by 4, so the answer is 12. The answer is B. 86. Again, you're given a table of values. It's a rate. You're going to integrate it, and it says using a trapezoidal sum, that's how you're going to integrate 3 intervals. So each interval is its own trapezoid. So the formula for a trapezoid is 1/2 the width. So it's 1/2 times 2, and then you add the bases. So this is what it's going to look like for each trapezoid. So it's 1/2 2, add the bases. So it's 24. 1/2, and then the next width is 5. So 2 to 7 is 5, and then add the bases. That's 14. The last trapezoid is 1/2. The width is 2, and then add the bases 9, and then calculate it, and you get the answer 68. So the answer is A. 87. We're there. So 87, the last one, it says the graph of a piecewise function is shown there. What's the value from -1 to 9 of this? And it goes 3 times f at x plus 2. So I'm going to rewrite this using properties of integration. So because it's adding, I can separate them. So let me show you. So it's going to end up being, you're going to separate it into 2 integrations. So the first integration is going to be 3 times f at x, but you can put the 3 in front. And the second one is plus 2 This second one, you don't need the graph at all. You're just going to do it algebraically. This one, you need the graph. From -1 to 9, how do you integrate off a graph? And so what I did is I found this area. This is a trapezoid. So I found that trapezoid area and made it negative. And then the second one is a triangle. So I found the area of this triangle, and it's positive. So this is positive. This is negative. And so for the trapezoid, the bases are 4 and 3. That's 7. And the height is 1. So it's 7 times 1, but it's half of that. So 7 times 1, but half of it. But it's a negative area. So that's where -3.5 comes from. 7 divided by 2, but it's negative. The area of that triangle, half the base times the height. So the base is 6, the height is 2. So the area of that triangle is 6. So it's 6 take away 3.5. So for f at x, in whole integration, 6 take away 3.5 is 2.5. So then if I come back here, the integration from -1 to 9, I did it geometrically, and the answer was 2.5. And then you take that answer times 3. The integration of 2 is just 2x from -1 to 9. You plug in the upper bound, that's 18. Subtract, plug in the lower bound, that's -2. So 18 subtract -2 is positive 20. So it's 20 plus 7.5. So the end answer is 27.5. Using properties of integration, can you integrate things geometrically? Can you integrate it algebraically? So I'm really proud of you. You finished your work. All that Unit 6 prep. That was long, and you worked, and I'm really proud of you. Mr. G Math, over and out.